Okay, so this is kind of a little pre-teaching of how the formulas work for our exponential equations. Okay, so whether they're decay or growth. And we can talk about what decay and growth is in class too. But they're just like they sound. Decay, things are getting smaller. Growth, things are getting bigger. Okay, so before we do that though, let's kind of back up and we're going to talk about recursive rules and explicit rules. Okay, so this is the explicit rule for our equation. Okay, I'm giving you two equations here, and I'm going to ask you to compare them. Okay, so our recursive rule is the current one, right? So the one that we want, so we call that f of n. And our previous term equals our previous term. So this is the one that's f of n minus 1 plus 3. So this is the same exact thing right here as this. Okay, we're just putting the words into kind of a function notation. All right, so then our next one, we could use the recursive rule, but it would be much harder to use the recursive rule on this one, and we'll talk about that in a second. All right, so in this one, our explicit rule, it says the current one equals the previous term plus 3. So what they're saying is, well, 10 plus 3 is 13. Well, if I want to get this one, I do 16. I do 13 plus 3 is 16. And then 16 plus 3 is what? Well, it's 19. So we could use the recursive rule on this one pretty easily because we know what the previous term is. So find the fourth value term, so 19. Okay, so we would use the recursive rule. You just need the previous term. So our explanation here would be the recursive rule. We would use recursive. We would use recursive because we know the previous term. Okay, so we know that what that previous term is. So that's really when the recursive rule is useful. It's like if you know what the previous one is and you know you just have to add 3 to it, or you know you have to multiply by something and you know the previous one, that's when we're talking about using the recursive rule. So in this case, it was just add 3, 3, 3, 3. Okay, well, what about our next one? Okay, so you can see that this one is different. It's the same kind of thing in the first two, right? Whereas 1, 2, and we're talking about the same problem. Okay, and we're talking about, hey, should we use the recursive rule or should we use the explicit rule for finding the term here? So f of n equals f of n minus 1 plus 3. So again, this is function notation for the recursive rule. Okay, so instead of finding the fourth term though, or even the third term, I'm asking you to find the 50th term. So that means that you would have to, if you were going to use the recursive rule, you would have to do 13 plus 3, 16 plus 3, 19 plus 3, and then 22, and then add 3, all the way up to 50. Well, that's not really an efficient way to do business, right? And so in this case, we would not want to use the recursive rule. We would want to use the explicit rule, because the explicit rule says that we can just substitute 50 in here, and then we end up with our answer. So we have 50 times 3, so y equals 3 times 50, or 50 times 3, however you want to look at it, okay? Which is 150, and then plus 7 is 157. Okay, so we'd use the explicit one on this one. So we would use the explicit rule. Or the explicit equation. Because we don't know the previous term. No, the previous term. Okay. So if you gotta find term number 1 million, like, doing the recursive rule is not an efficient way of doing things. You're going to have to do that literally 1 million times. You're going to have to add 3 1 million times. That sounds terrible. But if you have the explicit rule, and if you know what the rule is, then all you have to do is substitute a number into your explicit equation, and you're good to go. Like, you just solve it, okay? All right, let's see if I want to get into page 3 right now. All right. Yes, I do. Okay. All right, so now we're going to talk about the explicit and the recursive rules for our exponential functions. Okay, so here we go. All right, so the value of the fourth term is 80. Okay, the sequence is being doubled each time. Okay, and so our explicit equation is 5, the number 5, and we're going to multiply that by 2 to a power of x. Okay, so the recursive rule for the exponential functions is a little different. Okay, so we're now talking about f of n equals 2 times the previous term. And so we write the previous term in function notation as f of n minus 1. Okay? All right, so find the value of the fifth term. All right, well, we know that the fourth term is 80, right? So the fifth term is just being multiplied by 2 each time. So our fifth term is 80 times 2 equals 160. Okay, so we know the previous term here. All right, so the previous term is, we can use the recursive rule because we know the previous term. All right, so that's, again, that it would be a redundant thing of what we just wrote on the last one. Okay, so but this one's a little different. Okay, so find the value of the fourth term if the sequence is being doubled. Okay, so now we're going to use the recursive term, the recursive rule. All right, so instead of the fifth term, I'm finding the seventh term. And yeah, you could do multiply 2 more times, but I'm trying to get to the idea that you need to use the function here. Okay, so we're going to get our calculator, and you've got to pay attention on how we're putting our functions in here. Okay, so you've got to do your exponents first, so remember your order of operations. So multiply, use your exponents first. And the way that you do that on this calculator is we're going to have 2 to the x power. So in this case, it's going to be y equals 5 times 2 to the 7th power. Okay, so cool thing about the calculator is that you can actually substitute this entire thing in. You can say 5 times, we can open up a parenthesis and say 2, and this little tiny caret hat, whatever you want to call it, is saying an exponent. Okay, so that's how we tell it that we're saying 2 to the exponent 7. Close our parenthesis, put our number in, and we've got 640. Okay, so this little hat is how you're going to use your exponents. Okay, and we'll practice that a little bit in class 2. Okay, so let's go on to the next section. Let's put some of our stuff into practice. Okay, so evaluate the following equations when x is 1, 2, 3, 4, 5. Organize your inputs and outputs into the table. Okay, so our first equation is 4 to the x. Well, I want you to practice using the little caret hat. So we're going to say 4, and we're going to use exponent to the 1. And so our input is 4 to the 1, and in this case it's 4. Well, 4 to the first power is 1. Okay, so 4 to the second power, so we're going to go 4 to the second power, so make sure you're getting this little hat in there. Well, 4 squared is 16. That makes sense. Okay, and then you've got 3. So, sorry, 4 to the third power, and that's going to be 64. And then we've got 4 to the fourth power, and that's 256. And then we've got 4 to the fifth power, and that's going to be 1024. Okay, so our next one, this one's a little trickier now, okay, because we've got a negative in there. So I'm going to get this negative done, and then I'm going to have you guys do your best on the other ones and see if you can figure out how to get the answer. All right. Okay, so we're going to put that parenthesis in there. We're going to say -3 and then we're going to put our little hat in there, and we're going to say to the 1. Okay, and of course that's -3. And then our second one, you know what another cool thing is on this calculator? Without having to type all of this stuff back in, you can actually press the up arrow, scroll over to your 1, replace it with a 2, and hit enter. And now it's +9. Okay, so this says a negative times a negative. Okay, so now we're going to go back up, and we're going to change that 2 to a 3. We've got -27. And then we're going to go back up, and we're going to change that 3 to a 4. And you've got +81. You can see that it's going back and forth, positive and negative, right? Okay. And then I've got our last one is to the 5th power. And we've got -243. Okay. All right, so our next one, a lot of people get these two confused. I am going to do the first 2 on this one, and then I'm going to let you do the rest. These are different. The parentheses on this one is just around the 3. So this really says negative times 3 to the x. It's not going to repeat that negative. Okay, so you're going to say negative and then open your parentheses. So the last one we did, the negative was on the inside of the parentheses, and that's hugely different. Okay, so our current one is negative and then open your parentheses, and you're going to say to the 1st power and then close your parentheses. Okay, so this one's -3. And you can see that's the same. But what about the next one? So we're going to go back up, and we're going to change this to 2. So what do you think? Is it going to be -9, or is it going to be +9? So this one was +9, and they are different. So what do you think? Is it going to be -9 or +9? So you hit enter, and you get -9. Okay, so I'm going to let you do the rest of those. Okay, the rest of these are really similar on how you do them down here. Okay, so I'm going to let you guys do those in class, and I'm going to end my video right now.